Hi everyone, this is Dave Collins from Ann Arbor Guitars, coming today with a really odd and unique problem. Only the second time I've seen this in over 30 years of doing it. So rare and peculiar that hopefully you'll never have to experience it directly. This guitar came in this morning with some very interesting problems that occur under very particular circumstances. They're intermittent problems, which is the worst for diagnosis. When problems come and go, sometimes they just seem to disappear when they come in the shop and we can't find anything wrong with it. In this case, what happens consistently with the player is that when they first plug in the guitar, everything works fine, but after they've been playing for some period of time, a half an hour, the bridge pickup starts to fizzle out and then just goes completely dead. When I encountered a problem similar to this about 20 years ago, it took me quite a while to figure out, but the link that I found consistently with the failure was temperature. As the player who plays with their hand fixed on the bridge and does a lot of palm muting, playing right over the bridge pickup, just this few degrees of temperature change in here is enough to cause the pickup to fail. Now, if I turn the guitar on right now, both pickups seem to work perfectly fine. Now let's plug it into the meter and see what it tells us. And right now on the neck pickup, we're getting a reading of about 7.96 kiloohms, and on the bridge pickup about 8.73. But we are going to do a little test and see what happens when we let this pickup warm up a little bit. Here we are going to bring in our overhead lamp, and this is a very low temperature lamp. It's not very effective at heating things. It's an LED, very efficient. I can hold my hand right to the bulb. No risk to the finish. But we're gonna go ahead and put that lamp over there, let it sit for a few minutes and see what happens with the output of the pickup. And now it's been on there about a minute and you can see the readings starting to jump up, and there it goes. It jumped past 20K. Let's turn it on to the amp. Still coming through. But we're getting readings up approaching 30K, very irregular, hopping around a whole lot. And now it's been about 2 minutes and it's all over the map. It's starting to jump up past 70, 80K. Let's listen to it. And compared to the neck pickup, bridge, you can see it's much weaker. Starting to fizzle out entirely. And the readings now are, reading is right back down at 8.6. Oh, and jumped back up. You can see how off the chart irregular it is. So up approaching 200. At this point, now we are reading pretty much just the potentiometer. We've got 500K with a little bit of residual conductivity, intermittent, still from the coil itself. But cutting in and out, coming through a little bit, very distorted. Now what is happening in this pickup, and it's extremely rare, like I said, the last time I saw this was about 20 years ago, and this is only the second time I've seen this in over 30 years of working on guitars. It has to be an absolute perfect failure where somewhere in the coil, in one of the coils or one of the joints, there's just enough contact to be just barely touching, but with just a few degrees rise in temperature and a little bit of expansion of the metal in the coil, the physical movement separates that connection and breaks that connection and causes the pickup to go bad. What I suspect we're going to find with this is that one of the ends of one of the coils was not properly stripped, or if they're using a Solderex or some type of insulation that's supposed to melt when heated, it may not have been heated sufficiently. But I suspect that the end of one of the coil wires is still partially insulated. Solder is flowed around the insulation, but it created a little bit of a bubble of a gap rather than a true bond between the solder and the coil. So that wire is actually moving somewhat freely within the solder joint. We'll see. We'll tear it apart in just a minute and see what we can find, but I suspect that's what's going on here. And here we are up at a full 520K and staying fairly consistent now. So I think we've heated this enough to fully break that circuit. And now we're going to go ahead and pull the pickup out and see what we can find. And wide open. We've got the meter set at the 2 meg range. No reading at all. Double check that the probes are connected right. Yes. Getting continuity there. So first step is remove the cover. There's a lot of different ways to do this. I have always preferred solder braid over solder suckers, but whatever works best for you. Come in, wet the tip with a little bit just to create a heat bridge to really get the thing started. And that is some pretty sloppy soldering on there, but that's okay. It'll be better when we put it back together. All right, I think we have most of the solder removed, a little dirty, but we will clean that up later. Pickup cover slides off nice and neat. And our first step is going to be to come in and remove the tape around the end where the junction is between the two joints. Now we're getting a lot of jumping around on the meter again. Hopefully it'll stay failed. So let's come and peel off this little outer piece of tape. And we're going to go ahead and set this aside. We should be able to reuse that. If not, we do have replacement. And here is the connection to hot. And boy, I moved that around and I am getting all sorts of activity on the meter. That might actually be our failure point right there, but we're going to have to do some more testing to make sure of that. Well, I think we just found our problem right here. There is absolutely no solder. I gotta see if I can get this a little bit more of a macro shot here. There is simply no solder at all at the connection. I took off the insulation and just peeled the wires apart. They were wrapped and never touched with any kind of solder. That is a pretty unforgivable failure. Now, as tempting as it is to just write that off as the obvious solution that it is, solder that up and go put it back together, given this failure here, I have no faith in the rest of the pickup. So this whole pickup may have slid through with an entire step skipped at more than one point. So I am going to continue to peel back and make sure that everything else is soldered in as it should be. This one's a doozy. I have not seen this one before. The symptoms were the same thing that happened on the pickup 20 years ago, where they didn't strip the insulation off the magnet wire, and it created kind of a pocket of no bond but of melted insulation that allowed the wire to move inside the solder joint just a tiny bit and break the connection just with a few degrees of heat. With those removed, there's usually a little bit of a wax bond there we have to pop loose. We're going to pull both bobbins together. Okay, they did get a bit of solder in there. That's okay. The start of the first coil is soldered well to there. I don't know if I want to go in and test the joint in the middle. That would be a different phase of the job that isn't connected to this one. So let's just give it a test right there at the end that's not soldered. And we are up at around 9 kiloohms. Now this pickup is not actually 9 kiloohms typically. It's normally going to be about 8.6, somewhere in there. We're reading 9 right now because the whole coil has been heated. We intentionally heated it. As you heat the coils, the resistance goes up. So I would expect a slightly higher than normal reading on here. Everything there is typical and fine. So far, it looks to me that the rest of the solder joints, albeit a little bit aesthetically sloppy, are still intact. They're good. So we are going to mount the pickups back onto the base. We are going to solder the connection, what a novel idea, and reassemble this, and everything should be just fine. Now there is a little bit of oxidation on these wires. My favorite cleaner is good old Everclear grain alcohol. Denatured alcohol works perfectly fine, but why buy alcohol to get on your hands that's intentionally poisoned to make it undrinkable? Not that I would consider this drinkable, but it's essentially 95% alcohol and a little bit of Kim wipes, and we can go in and clean and prep the ends of the wire here. Try and remove as much contaminant as we can, as much dirt and grime and tape residue from being taped up without ever being soldered. The solder flux will carry away some of it, but we really should try and clean all the surfaces as best possible beforehand. And now we are going to wrap the wire as they originally did, but this time we are also going to solder it. A little bit of a heat bridge there, and then we flow in from the other side. It looks like it's wicking into the wire and bonding very well, just as we like. Okay, so we basically had to finish manufacturing of the pickup. We'll test it on the meter. We're back down at 8.95. Again, a little bit over resistance right now because of the temperature. So now we are going to go ahead and finish cleaning off some of the solder, some of the prior solder from the back plate. And then we are going to do the same thing with the edges of the cover. Make sure we clean up any residual bits of solder left on there. That actually looks pretty clean. Leave a little bit of tinning on the edge maybe, but no solder globs. And then back in with our alcohol and Kim wipes, and we are just going to get all of that old flux off of there, try and clean it up as best we can. That should clean it up quite nice. Clean up this, also kind of rubbing off wax from any areas that we might have to solder to. Okay, another Kim wipe to come in and dry everything off. We're going to go ahead and reuse the original tape for insulation. This is just a friction tape, essentially, as long as we can get a good seal there. Remount the tape between the bobbins, and everything looks secure there. Put the cover back on. There's still a little bit of wax residue here on top of the bobbin. If there wasn't, sometimes I actually like to melt a little bit of wax, sometimes with a heat gun, and put it in there just to keep any vibration between the cover. That sympathetic microphonic vibration of the metal is just awful, so we do like a little bit of wax that we can melt back in between. And clean up our iron from that nasty desoldering braid and all that flux. Sometimes with aftermarket covers, I'll have to actually clamp the covers. They can be sprung out a little bit where they're too wide and actually have problems fitting into the rings. These ones look fine. They've already been mounted once cleanly and look like they should be no problem. There's a nice smooth solder connection there. We don't need too much here. I like to have it flowed fairly thin across here. There we go. That's a little bit prettier than the original solder that it came in with, and the pickup actually works now. So that was certainly a unique one. Not the first time I've seen such a failure of forgetting to solder something at the factory, but the first time I've seen one that was so consistently dependent on temperature, where it would work perfectly fine when the guitar hadn't been played for a few hours, but as soon as you started playing it 10 minutes, 30 minutes into it, the proximity of the player's hand to the bridge pickup was enough to warm it up, just enough for metal to expand and to break that joint somehow. So anyway, way to go, Gibson. I guess it can happen to any manufacturer, and the fact that this is the first time I've seen this in 20 years at least might give a pass. But so I hope you found watching this process of diagnosis and evaluation and repair interesting. If you did, please be sure to subscribe. We'll be coming out with more videos as time allows. Thanks so much, and we'll see you soon.